Okay, so today we're going to look at bearings. Our learning intention is to understand the knowledge of what true bearings are and compass bearings. Notice that there's two. And the skill in applying these bearings and using trigonometry to solve problems. So we'll be successful if we can calculate correctly the true bearings, if we can calculate correctly compass bearings, correctly calculate, convert between true and compass bearings, so go from true bearings to compass and compass bearings to true, and correctly apply trigonometry with bearings to find missing angles or missing sides. Okay, so as we said, there are two types of bearings. We're going to start with the compass bearings. So compass bearings you know as north, south, east and west. And so, for example, the in-between part, such as this between north and east, so the in-between is north-east. And notice that I've had a little gap here. I made a little gap between the two letters. Halfway between south and east is southeast. And obviously the opposite between west is southwest. And here is northwest. Okay. So compass bearings always start north or south. So the first letter is either N or S. Yeah, so northeast, north, northwest, southwest, southeast, south. Okay. We then give a degree that's going to be between 0 and 90 of how far it's turning east or west. So for example, if I'm here and I've got 45 degrees, or 45 degrees turns to the east, this compass bearing is now north 45 degrees east. Yeah. Same thing here, we've got south. I'm turning 45 degrees to the easterly direction, so I'm south 45 degrees east. Here I'm still turning 45 degrees, but I'm going to the west, so south first. I turn 45 degrees west with a west direction. And here would be north 45 degrees west. If I'm going directly east or directly west, I say I'm going due east or due west. So due east or due west. You can say you're going due north or due south. That's, that's going north or going south. Okay. So they're compass bearings. Compass bearing starts with north or south first, then a degree between 0 and 90 degrees of how far it's turning east or west. True bearings, well, they start at north being 0, 0, 0 degrees true. So true bearings always have three numbers. And then we measure how far we are turning in a revolution from facing north. So for example, if I keep going in a circle, if I get north 45 degrees east, well, that's just 0, 45 degrees true. If I keep turning, my due east becomes 0, 90 degrees true. Keep going further, I'm adding 45 degrees. That's going to be 135 degrees true. Keep turning, I get to 180 degrees true. Add an extra 45, I get to 225 degrees true. Keeping going, now I get to 270. Adding another 45, I get to 315. And then if I went to the full revolution, I'll get back and I'll get to 360 degrees true. if I did a complete full revolution. So true bearing start at north being 0, 0, 0, and measures how much of a revolution or a turn from facing north the person makes. Let's do some examples. Okay. So it says provide the compass bearing and the true bearings for each image. Okay, I'm going to do compass bearings in black, and then I'll do my true bearings in blue. Okay. Well, here, there's my line. I'm facing north. I'm moving 30 degrees, and I'm going in an easterly direction. Okay. Here, I'm facing south. I actually want to know what this measurement is here. Yeah, so I do 90 minus 15 to know that this is 75 degrees. And so I'm moving 75 degrees in an easterly direction. Here I'm still facing north. I actually want to know what this part is. So 90 minus 20 is 70. That's 70 degrees, and I'm moving to the east. Here I'm facing south. I'm going south. I want to know what this part is here, so I do 90 minus 35. And that's 55 degrees, so I've got 55 degrees, and I'm going in a westerly direction. That's 12 up here, so I'll maybe write it bigger. That's 12 degrees. Okay. So here I'm facing north, and I'm moving 12 degrees to the west. And so here, that's 3 degrees and 15. I'm still facing north, and I want to minus, because I really want this part here. So I've got 90 minus 3 degrees and 15 minutes. And I get 86 degrees and 45 minutes to the west. Okay. So true bearings, they start at north and measure how much of a revolution or a turn they make from north. So this one, we're just moving 30 degrees, so that's 0, 30. Here we start at north, we go to 90, and then we add 15. So we're looking at all this part here. And so 90 plus 15 is 105 degrees. True. Here we notice that we're starting at this part, and we measured that shaded bit was 70. So we're actually 70 degrees true. Here we're starting at north. We do a kind of a complete flip, that's 180, and then I'm going to add the 55, because that's in this part here is 55. So 180 plus 55, we get 235 degrees true. Okay, so here we're starting at north, we're going to go all the way around, but we're not going to do a full revolution, so we're actually going to do 360 minus 12. So 360 minus 12, so we actually turn 348 degrees true. Okay. Here, same thing, we're pretty much doing three quarters of a turn, which is 270 degrees. Then we're going to add the 3 degrees 15. So we get 273 degrees true and 15 minutes. Okay. Let's do some worked examples using trigonometry. Alright, a plane leaves Sydney and flies on a bearing of 195 degrees for 3,500 kilometres. So the first thing we really want to do is we kind of want to draw a diagram. So the first thing I always do is I have a kind of, in my middle page I do my across. Okay, there's my north. All right, it says a plane leaves Sydney, so let's say this dot here is Sydney, and flies on a bearing of 195 degrees. So 195 degrees, that's a true bearing, so we get 180 plus a little bit more. So really, that's our plane flight path. Okay, so this whole thing here was 195 degrees. And so he flies on a bearing for 3,500 kilometers. Okay. The first question says, how far south is the plane from Sydney? So remember that this dot here in the middle is Sydney. I can technically make a right angle triangle. Okay. Using my compass kind of coordinates. There's my triangle. And I really want to find, if that's my little plane, so plane, how far south he is. Well, that's the same measurement here. So let's call that A. Let's call that letter A. All right. So using that, I know what this angle in the triangle that I've just made is. Yeah, because I know that this is a straight line, which is 180. 180 minus 195 minus 180 means that this part in here is 15 degrees. So what I actually have is I have a triangle of 15 degrees and a hypotenuse. So I actually have adjacent hypotenuse. I have a cos. So I can do cos theta is A over h. Cos was 15 degrees. A, the adjacent, we're not quite sure. That's what we're trying to find. The hypotenuse is 3,500. If I multiply both sides by 3,500, I get A equals 3,500 cos of 15. Plug that into our calculator. I'm in degree mode, yep. So the plane is 3,380. Let's do it to the nearest meter, or nearest kilometer. So 81 kilometers. Okay. Let's do part 2. It says how far west. So west is going this way, so let's call that B. We want to find out this measurement. Okay. So now that I still have that, I'm now looking at the opposite and the opposite and the hypotenuse. So here's my triangle. I've got this, that's 15 degrees. I want to find that. Yep, so I now have sine. So sine theta equals O over h. Sine 15, because theta is 15. Opposite is what we don't know, and the h is 3,500. So B is worth 3,500 sine 15. Using our calculator, 3,500 sine 15 gives us, and let's do it to the nearest kilometre again, so 906 kilometres. Note that I'm constantly writing what I'm rounding it down to, and I'm using my measurement as well. Yep. So, last question says, what is the bearing of Sydney from the plane? So remember this dot here was Sydney. We actually want to find the bearing of Sydney from the plane. So what I do is I do a little cross here on my little plane section. Yeah, and what I really want to do is I actually want to know what this angle here is. Okay, so that I can figure out that bearing. And so what I can do is, I know this is a right angle triangle. This is 15, that is 90. So 90 take away 15, that must be 75. This is also 90 degrees. So this means that this is 15, and we could have done that by still using parallel lines, our knowledge of parallel lines. So this measurement is the same as that measurement. So technically, if I'm going to use compass bearings, Sydney is north, and it's 15 degrees, and it's to the east of the plane. But if I was to do true bearings, so do that in blue, it is technically 15 degrees true. Okay. Let's do another example. Zach leaves home and walks 7.2 kilometres on a bearing of 0.075. He then turns and walks 5.1 kilometres on a bearing of 115, and then he is then due east of his home. Let's try to draw this. So, starting in the middle. Alright. He leaves and walks 7.2 kilometres. So here is where I start. I can put S. Yep. And a bearing of 75 degrees. So 75 degrees is somewhere here. Okay. And so that was 7.2 kilometres. He then turns, so from here, he then turns and walks 5.1 kilometres on a bearing of 115. So from here, there's 90, and 115 would be in this quadrant somewhere. So here's the bearing of 115 degrees until he's due east. So I'm going alright. $5.1 until he is due east from his home. So that's his home. Okay. And there's my little image. Okay. What is the furthest north that Zach walks? So we really want to find out this distance here, how far north he has gone. So I could kind of draw a triangle here and try to find out this, or I can notice that that's going to be the same length. So I want to find out what this, we'll call that A, what that distance is. So we do know if that's 75, then this angle in here has to be 15 degrees as well, because that makes a 9-degree angle. So once again, I have 15 degrees, I have opposite, and now I have a hypotenuse of 7.2, so I actually have sine. So sine theta is O over H. Theta was 15 degrees. O is what we don't know, and the H was 7.2. Okay. So A is 7.2 sine 15. Using our calculator, we get 1. Let's do one decimal place, 1.9 kilometers. Okay, to 1 dp. And the reason I've chosen 1 dp is because everything else has been given to us in 1 dp, so I'm going to return it, the answer in a similar format as the question is. So he's approximately 1.9 kilometers north from home. Okay, so how far is he from home? So we really want to figure out this distance here. Okay, what we're going to do in this case, I'm going to try to, because we're only really working with right angle triangles, what I'm going to try to do is I'm going to calculate what this measurement is here, which is, let's call that B. I'm going to measure then what this part is, that's C. I'm going to add them together. Yeah. So we want to figure out this kind of distance. Let me just double check one thing. So this angle in here is going to be 180 take away 115. That's 65. And this is, this would be 75. Yeah, 75. Okay. Alright. Cool. So if I wanted to figure out what B was, so I have my adjacent and my hypotenuse, so I actually have cos theta equals A over H. Cos is 15. My adjacent is B over the hypotenuse of 7.2. So B is 7.2 cos 15. I won't find that out just yet because I actually then want to add B plus C. Okay. And so and then this part here, I've got an angle. I have opposite over hypotenuse, that's a sine. So sine theta equals O over H. Theta was 65 degrees. O is C, the hypotenuse is 5.1. So C is worth 5.1 sine 65. Okay. And now what I'm going to do is I'm going to add this combination into my calculator. So 7.2 cos 15 plus 5.1 sine 65 gives me 11 we'll do it to one decimal place, we'll do it to 6 kilometers 1 dp. The reason why I do this is so as not to have rounding errors. So if I do 7.2 cos 15 and I rounded it here, that technically gives me 7. If I did 5.1 sine 65 and I rounded it here, that gives me 4.6. Yep, so this wasn't too bad, okay, because if I added those two, I still get 11.6. But occasionally you can get rounding errors from that, so that's why I've left the process at the end. Okay. Now, if some of you have learnt the cosine rule, there's many ways to find different sides. Here I had to use 2 right angle triangles if all I knew was right angle triangle. If I knew the cosine rule is that so c squared equals a squared plus b squared minus 2ab cos c. And knowing that I have that angle, I could figure it out as c squared equals 7.2 squared plus 5.1 squared minus 2 lots of 7.2 times 5.1 cos 75 plus 65 is 140. Okay. So c squared, if I plug that into the calculator, 7.2 squared plus 5.1 squared minus 2 lots of 7.2, 5.1 cos 140 gives me 134.1083039. If I square root that, I get 11.6 kilometers 1 dp, which is exactly the same as doing it in 2 separate triangles. Okay, so it just depends on what kind of how much trigonometry you do know. Okay, my last example. All right, we have a motorbike and a car that leave a service station at the same time. So let's say here's a service station. Okay. The motorbike travels on a bearing of 75 degrees. So that's somewhere like here. So that's the motorbike. And the car travels 12 kilometers on a bearing of 110. So 110 is somewhere here. And until the car, so here's the car, until the bearing of the motorbike from the car is 310. Yeah. So that all the way around is 310. Okay. So we want to find how far has the motorbike travelled to the nearest kilometre. So we know that this was 12 kilometres. And we really want to know what this measurement is here. Okay. If we look at it, let's just test some things. Okay. If that's 75 degrees, parallel lines, that means that this here will be 75 degrees as well. Okay. That's 310, so this is 50. Okay. So and here, yeah, that would be 50. And this would be 50 as well. Okay, making that 135. No, 125. Yeah. Okay. So in this case, here I would have to kind of use, if I'm trying to find that, I'm going to have to use, the cos rule. I've got that. However, if we only want to find out how far the motorbike was travelled to the nearest kilometre, that distance, we could just have this triangle. But we have this information. Okay. In this case, I'm going to actually have to use the sine rule, because what I have is I have a triangle. I have 12 kilometers, I have 125, and I have x, and I want to figure out what that measurement is. I don't have any more information. Okay, so this is a nice, do I have this angle here? So that's 50, oh, that's 110. So 110 minus 75 gives me 35 degrees here. Okay. 180 is a triangle, minus 125 minus 35 gives me 20 degrees here. And actually here now I'll probably use the sine rule. The sine rule in this case means that sine A over A equals sine B over B. Currently, let's say sine A was 25, and that's 12, and then sine 20 over x. Using some algebra, I've got x sine 125 equals 12 sine 20 divided by sine 125 on both sides. So now we have 12 sine 20 divided by sine 125. X would be 5 kilometers, and that's the nearest kilometer. Okay. Yep. So this one we wouldn't be able to do right angle triangles. We could eventually, but it would just be a lot of work to get to that. So we've shown you how to use bearings to do sine rules, a cosine rule, as well as right angle triangles. Okay, thank you.